Hello, everyone, and today we will go over the topic of balancing hydrocarbon equations. Hydrocarbons are simply molecules or compounds that contain carbon and hydrogen atoms. So we will start by balancing this equation here. This equation is the combustion of butane. So here we're going to first count the number of atoms on both sides of the equation of a particular type. So we know that there are going to be carbon atoms on both sides of the equation. We can see this here. So there's carbon atoms on the left side of the equation. The left side of the equation is called the reactant side. The right side is called the product side. So here we have carbon in both the reactants and products. Our goal is to make sure that the number of the same kind of atoms is the same on both sides of the equation to ensure that the law of mass conservation is obeyed and to ensure that the mass of the products and reactants is constant. So here we have how many carbon atoms? We have 4 carbon atoms on the reactant side, we can see, because we have this 4 in the subscript. How many carbon atoms do we have on the right side? We have 1 carbon atom. If you don't see anything in the subscript here underneath the C, then you know there's just 1 carbon atom there. So this isn't balanced, so to make the number of carbon atoms equal, you have to multiply this by 4, right? If you're going to multiply this carbon by 4, you have to put a 4 here. Now, it's important to know that this 4 is now not only in front of the carbon, but also in front of the oxygen, right? So let's see how many oxygens we had to begin with. We had 2 oxygens to begin with. All right, so we're going to put a 2 here. We're also going to have to multiply this by 4 as well. Why? Because now there's 4 molecules of carbon dioxide. So let's continue. How many hydrogen atoms do we see on the left side? We have 8. How do we know that? Because there's an 8 in the subscript here. There's no other hydrogen atom sources on the reactant side. How many hydrogen atoms do we see here? We see 2, right? So we have 2 here. How many oxygen atoms do we see on the left side? We see 2, right? How many oxygen atoms do we have from the carbon dioxide? We have 2 because each carbon dioxide molecule has 2. But in this case, we multiplied it by, we have 8 because we needed to make 4 carbon dioxide molecules. Here we have 1 oxygen atom from the water. So let's see. Now that we took account of the atoms that we have, let us see if we have the same number of atoms of each type. We have 4 carbon atoms, 4 carbon atoms, 8 hydrogen atoms here, 2 hydrogen atoms here. So we're going to multiply this by 4 to make this number equal. Let's put a 4 here then, because we're going to have to increase the number of hydrogen atoms by a factor of 4. So we're going to require 4 water molecules. This oxygen right here, it's also in front of the 4. So we're going to do a times 4 here as well, right? So now we have 8 hydrogens, 4 carbons, 4 carbons. Here we have 8 oxygens from the carbon dioxide, and we have 4 oxygens from the water. So we in total have 12 oxygens.
Does your scanner work?
Yeah, it works.
Okay, thanks.
So what you have here is you have 12 oxygens, right? 12 oxygens. You have 2 oxygens on the other side. So what number can you multiply this 2 by to make 12? What do you guys think? It would be 6, right? So in this case, we have 12 here, 12 here, 8 here, 8 here, 4 here, 4 here. At this point, we're balanced, but we need to put this 6 in this spot, right? Whatever numbers we multiply, these are called the coefficients. These are the factors by which we increase the number of molecules that contain the atoms that we're interested in. So in this case, we did this to make everything balanced. If anyone has any questions, please email me at my school email. This recording will be available to you in Zoom. So here we have, okay, so to start, we have 2 carbons, right? I got this number from here. We have 1 carbon here, right? Because we have no subscript here. How many hydrogens do we have? We have 2 here. How many hydrogens do we have here? We have 2 here. How many oxygens? We have 2, right? How many oxygens from the carbon dioxide molecule here? 2, right? 2. How many oxygens from the water molecule? 1, right? So is this balanced? Meaning, is the number of carbon atoms the same on both sides? No, it's not. So we have to make it balanced. 2 here. Put a 2 here, we also have to put in front of the oxygen, right? So now we have a total of 2 carbons here, 2 carbons here. We have 2 hydrogens here, 2 hydrogens here. We have 2 oxygens here, but 4 oxygens here. So perhaps, actually no, 4 from here and another 1 from here. So we have an odd number of oxygens in the product size, which is 5. And we have an even number of oxygens here. So there's, unless you use fractional coefficients, you're not going to be able to equate the even and the odd numbers of atoms on opposite sides of the equation. So you're going to have to make this side even. So you're going to have to multiply this by 2. If you multiply this by 2, right, your oxygens are here. You're going to have to put a 2 here. If you do this, you're going to have to do this to the hydrogens because you're putting a 2 in front of the hydrogen as well, right? So now you have 2 hydrogens on the left, 4 on the right, and you have 4 plus 2, 6 oxygens in the left. So to make the number of hydrogens equal, you have to multiply this by 2. If you do that, you're going to have to put a 2 here, and you're going to have to put a 2 in front of the carbon because the carbon is in front of this 2, which was used to multiply the hydrogen. So now let's see, 4 here. Okay, so now the carbons are not balanced. We're going to multiply this by 4. 4 carbons here. Let's put a 4 here. Let's see, so we're going to have 4 carbons here. And we're going to have 8 oxygens from the from the 4 molecules of carbon dioxide. And we're going to have 2 oxygens from here, right? So we have 10 oxygens on the right side, only 2 oxygens on the left side. So to make this number of oxygens balance with them, multiply this by 5. And we're going to have to get this. Let's see if this makes sense. So we have 2, 5, 4, and 2 as the coefficients. We have 4 carbons on the left, 4 carbons on the right, 4 hydrogens on the left, 4 hydrogens on the right. Then we're going to have 10 oxygens on the left, and we're going to have 8 here, and then 2 here, 10 on the right. So at this point, we're balanced, and this would be our complete answer to this problem. All right, so let's go on to the next part. So here we have another hydrocarbon. And we have a reaction where the hydrocarbon reacts with oxygen to produce carbon dioxide and water. So how many carbons do we have on the left side? We have 3. How many carbons do we have on the right side? We have 1. How many hydrogens on the left? We have 8. How many hydrogens do we have on the right? We have 2. How many oxygens on the left? We have 2. Here from this oxygen. On the right, we have 2 oxygen atoms from the carbon dioxide molecule, and we have 1 oxygen atom from the water molecule, right? Okay, so we're gonna have to figure out how to make this balance. So the carbons are not balanced. We have 3 on the left, 1 on the right. So let's multiply this carbon by 3. Maybe this will help, we'll have to see. We put a 3 here, right? We're also putting this 3 in front of the O2. So we're going to put it times 3 here as well. Now the hydrogens, we've got, let's see what we got here. We've got 8 hydrogens here, 2 here. So we have to multiply this by 4. Put a 4 here. This 4 goes in front of the oxygen. This 4 here goes in front of the oxygen that's here. So that means that we're going to have to put a 4 here. Okay, so now let's see what we've got here. We've got the same number of carbons, the same number of hydrogens. Okay, now we've got what here? We've got 6 oxygens here. We've got 4 oxygens here. We have a total of 10 oxygens on the left side. So to make 10 oxygens on the 10 oxygens on the right side, right? So this is 6, this is 4, total of 10, right? 10 O atoms total. We have just 2 on the left side. So what number can you multiply this number by? What coefficient can you multiply this 2 by, which comes from here? Get 10. The answer would be times 5, right? So now we've got 5 times 5, whatever we multiply by, whatever number of atoms that we derive from the formula that we multiply by, that's the coefficient. This is the scaling factor by which we increase the number of chemical species that contain the atoms of interest. So if we're going to make 5 times more oxygen in the left, we're going to have to put a 5 here. So we've got 10 oxygens on the left, 10 oxygen atoms on the right, 8 hydrogen atoms on the right, 8 hydrogen atoms on the left, 3 carbon atoms on the left, 3 carbon atoms on the right. So at this point, we have equal numbers of atoms of each kind on both sides of the equation. All right, so now let's go on to this problem here. So we have the combustion of another hydrocarbon. How many carbons do we have on the left side? We check the coefficient, the subscript that is underneath the symbol of the atom that we're interested in. So we have 5 here. How many carbon atoms do we have on the right side? Here we have 1, right? How many hydrogen atoms do we have here? We have 12, right? How many hydrogen atoms do we have here? On the right side, we have 2. How many oxygen atoms do we have on the left side? We have 2. How many oxygen atoms do we have on the right side from carbon dioxide? We have 2. How many oxygen atoms do we see on the right side from the water? We have 1, right? So we're gonna have to figure out how to balance this. So we're gonna have to multiply this side by 5. Okay. We're gonna put this 5 in front of the carbon and the oxygen. So we're gonna have to multiply this by 5 as well. Now, the carbons are balanced because we have 5 on both sides of the equation, but the hydrogens are not. So we're going to multiply this by 6 to make the number of hydrogens equal, and we're going to have to put a 6 in here. But know that multiplying this water molecule by 6 will ensure that this oxygen is also multiplied by 6. So now we have equal numbers of hydrogens, equal numbers of carbon. We have 1 oxygen on the left, but we have 10 oxygens from the carbon dioxide, and we have 6 oxygens from the 6 molecules of water. So our total oxygen, 16, so total oxygen, 16 on right, total O atoms. Total number of oxygen atoms is 16 on the right. We have to make the number of oxygens equal. So if we only have 2 oxygen atoms here, how many molecules of oxygen do we need on the left to make a total of 16 atoms if each molecule of oxygen has 2 atoms? The answer would be times 8, right? Times 8. Put an 8 here. So now we have 16 oxygens on the left, 16 oxygens on the right, 12 hydrogens on the left, 12 hydrogens on the right, 5 carbons on the left, 5 carbons on the right. All right, so let's do this final problem here. So we've got how many carbons do we have on the left side? We have 7. How many carbon atoms do we have on the right side? We have 1. How many hydrogens do we have on the left? We have 16. How many hydrogens do we have on the right? We have 2. How many oxygens do we have on the left side? We have 2. All right, how many oxygens do we have on the right side? We have 2. How many oxygens do we have on the right side from the water molecule? We have just 1, because each water molecule has 1 oxygen, right? All right, so we don't have equal numbers of carbons on both sides. So we're going to multiply this by 7. So we have to have 7 carbon dioxide molecules, right? Carbon dioxide is a molecule that has both carbon and oxygen in it. If each molecule of carbon dioxide has 2 oxygens in it, and you're going to have 7 of these molecules, you're going to have to multiply this oxygen, this set of oxygen atoms that comes from the carbon dioxide molecule by 7 as well. Because this 7 is also in front of the O2. This O2 is here, so it's multiplied by 7. Now, we have equal numbers of carbons, but we don't have equal numbers of hydrogens. We have 16 on the left. We have only 2 on the right. So we're going to have to multiply this by 8 to make the number of hydrogens equal. So we're going to have to put an 8 here. Now we have 8 water molecules. This O is in front of the 8. So we're going to have to multiply this O1. This O1 comes from here by 8 because the 8 is in front of that O. So now we have 8 oxygen atoms from the 8 water molecules, and we have 14 14 oxygen atoms from the carbon dioxide, right? So our total number of oxygen atoms is going to be 22, right? So we're going to have to multiply this by 11. All right, so we're going to have 11 oxygen molecules on the left to equalize the 22 oxygen atoms from the right. Okay, do we have equal numbers of hydrogens? We have 16 on the right from the 8 water molecules, 16 on the left, 7 carbon atoms on the left, 7 carbon atoms on the right. So that's it. That would be how to do this worksheet on balancing equations involving hydrocarbons. If anyone has any questions, please reach out to me via email. So this will be it. Please don't hesitate to provide assistance to your fellow classmates so that you can earn extra credit by doing so. Please email me with whom you've assisted so that I can reward extra credit appropriately. Thank you and have a good rest of the week, and please stay safe.